Okay, let's give you guys some practice. So find the domain for this function. So press pause and have a go. Okay, so to do this, when you're trying to find the domain, try to look at the function and try and figure out when it will break down. Well, this thing will break down when it's less than 0. So we need to make the demand that this thing here to be bigger or equal to 0. And then looking at this, well, this thing here breaks down when it's negative, when the denominator is 0. So our second demand would be that this thing here can never be 0. So add x to both sides, meaning that y equals x here. Anything on this line, the whole thing will break down. This whole thing here will break down. Therefore, the whole function will break down. So in your mind, draw your domain. You've got your y-axis, x-axis, and a diagonal line. Anything on this line, the whole function will break down. So now looking at this, we ultimately want to times both sides by this bubble here. But when it comes to inequalities, if you times by a negative number, the sign switches over. But the thing is, this thing here could be positive, or there are times when it's positive, there are times when it's negative. So let's just consider when this is positive, meaning let's just consider this region here above the diagonal line. So above the diagonal line, this thing here will always be positive. Well, if this thing is always positive, when you multiply both sides by this thing here, the inequality will stay the same. So hang on, let's start again here. So let's consider this region here. So for y bigger than x, so we are looking at this region here. For y bigger than x, we know that this thing will always be positive. So multiply both sides by this thing here. So 0 times this thing here will be 0, will be 0, and then this thing here will then just become this thing here. And remember, the reason why we're able to do that is because we know that this thing will always be positive in this region. Okay, so we are currently at this stage here. So now looking at our natural log graph. So we're looking at our natural log graph. We need it to be bigger or equal to 0. So we need it to be. So we are basically interested in this region here. So now from here, exponentiate both sides with base e. That will then take you to here. E to the power 0 is 1, and in a way these two cancel each other out, leaving you with this. And by the way, the reason why when it comes to inequalities, let's say let's look at the e graph. E to the power x looks like this. Well, even when you're working with inequalities, suppose -3 we know is less than -2. -3 is less than -2. So when you e to the power -3 will be less than e to the power of -2. So when it comes to inequalities, you can exponentiate both sides with base e. If you look at, let's say, 2 and 3, we know that 2 is less than 3. E to the power of 2 will definitely be less than or equal to e to the power of 3. So when you're here, even though it's an inequality, you can actually exponentiate both sides with base e. So that will then take you to this, and then add 4 to both sides. That will then give you this. So hopefully you can recognize that this is a circle of radius √5, and it's been shifted across by 1 to the right by 1. So looking at our domain, earlier we established that along this diagonal line, y equals x, it will break down. But then we consider this region only. Well, when we consider this region only, we came to this stage here. So that means it's a circle of radius root 5, and it's been shifted across by 1. It's been shifted across, so the center is right here. So that means well, in the region where y is bigger than x, we need the circle to be bigger than the radius of root 5. So this is the radius of root 5. So basically we are interested in this region here. This region here. We are interested in everything on the outside. Okay, so that's the first part done. So now going back to our earlier demand, right from the start we said we demand that this thing to be bigger or equal to 0. And now we need to consider this region here where y is less than x. So now for the region where y is less than x, that's this region here, let's see what happens. Well, when y is less than x, we know that this thing here would be negative. It would definitely be negative. It would definitely be negative. So when you multiply this, when you times a negative number, the inequality switches over. So hang on. So in the region where y is less than x, multiply both sides by this, and the inequality will switch over. So that would then take us to here. Okay. So now hang on. So that would then take us to here. So now let me think. Now exponentiate both sides with base e. That will then take you to here, and then well, these two in a way cancel each other out. So this thing here will then become this. E to the power of 0 is 1. So when you're here, what it's saying is that, well, what it's saying is that we are interested in this thing here being less than or equal to 0, or 0 is here. So basically we're interested in this region here. So hang on, let's start again. So we are interested in this thing being less than or equal to 1. So we are interested in this. But then looking at this, the natural log of anything, we require this thing here to be greater or equal to 0, because anything in the negative realm, this whole thing will break down. So from here we need to make two demands. We need to make this demand, and we also need to make this demand. So this thing here is saying that, well, make sure this bubble here is always bigger than 0. So that's from here all the way to here. And this thing here is saying make sure it's less than 1. So we are interested in this region here. So this arrow here basically represents this, and then this arrow here represents this. So now combining these two together will then give us this. So basically looking at this, it will then give us this, and then looking at this, it will then give us this. So this thing here must be trapped in between 0 and 1. So now add 4. So looking at this, add 4 to over here. That will then give us this. And then now looking at this, add 4. That will then give us this. So we require a circle to be bigger than a radius of 2 and smaller than the radius of root 5. So what that means is, in this region here where y is less than x, we require the circle to be bigger than the radius of 2. So this is radius of 2, and this is radius of root 5. So in this region here, the region that we're interested in is this bit here. It's in between radius of 2 and radius of root 5. So we are interested in this. So our domain, hang on. So our domain is actually everything out here, and in the region where y is less than x, our domain is inside here. So now we need to put this into in writing. So now the domain. Hang on, let me just shift this across. Bear with me. So so now we need to put this down in writing. So our domain is given by this thing here. So our domain is xy being on the 2D plane, such that in the region where y is bigger than x, that's this region here where y is bigger than x, comma, our circle, which has been shifted across by 1, must be bigger than radius root 2. So this is radius root 2. It must be bigger. So that's this region here. That's this region here. And then union with x and y on the 2D plane, such that in the region where y is less than x, that's this region here, it turns out that our circle must be trapped in, it must be bigger than radius of 2. That's this thing here, radius of 2, and it has to be smaller or equal to radius of root 5. That's this. So basically, that's this region here. So this is our domain in writing. Okay, and then let's compare this to our original our original surface. So you've got the circle here. So this is our diagonal line here, y equals x. So this is our diagonal line here, y equals x. Don't forget the origin is somewhere around here. This is our x-axis. This is our y-axis. So you've got our circle here. And then in the region where y is bigger than x, you can see that this region here is this region here. And then you've got this tiny band here, which is this tiny band here. And then you've got our circle. Okay? So our domain is given by this.